Good day, everyone. Good day, good morning, good evening, wherever you're in the world. Welcome to another Power BI session powered by UrBizEdge. So for today's session, we're having a special guest, which is also an MVP by the name of Nicholas. We'll be taking us on the topic Power BI performance tuning. So this program is brought to you by the partnership between Enterprise DNA and UrBizEdge. So I'll give you a brief about Enterprise DNA. Their main goal is basically powering Power BI users all over the world. They also host some Power BI competition. You can also check them out on LinkedIn at Enterprise DNA. You can also get a membership and also learn a lot about Power BI and also some more information about Power BI. So UrBizEdge, for us, UrBizEdge, we're registered Microsoft Excel consulting, financial modeling, business intelligence, data analysis, and also enterprise solution firm in Nigeria. We specialize in helping companies and high value professionals be on top of their business data. We're also the developer of some Excel tools such as the Nigerian Finance Market Analysis tool, which you can find on Microsoft Office Store. Also, the developer of the Nigerian Stock Analysis Dashboard. As you all know, we're also a training company in Lagos, Nigeria. We also have branches in Lagos, Port Harcourt, and Abuja. So this is our upcoming training on the 18th of November. We're having in-depth Excel training, executive dashboard, and business data analysis using Excel. Also the same date on the 18th, we'll be having big data analysis, Power Query, Power Pivot, and VBA in Excel. So I'll give you a brief about our special guest, Nicholas. He's also someone I'm actually very excited. I think I'm the most excited person right now. So he's making music for data. He's a Power BI and also a SQL Server addict, Microsoft Data Power Platform MVP, a Pluralsight Author, a blogger, and also a speaker. Interested in everything related to data and also eager to extract valuable information from raw data in the most effective way. Multiple years of experience working with basically Microsoft data platforms such as SQL Server, SSAS, SSIS, SSRS, and also Power BI. So our special guest also a Microsoft MVP. So no further ado, I'll hand over the session to Nicholas. So Nicholas, I'll stop sharing my screen right about now and I'll go background.
Thank you very much, Temidayo. It's a pleasure to be with you today here. Let me just start sharing my screen, and yeah, I think we can slowly start. Hi everyone from my side. Good morning, good afternoon, good evening. With these virtual sessions, you never know from which part of the world people are joining, so it's always, I would say, a good practice to wish all times of the day, like morning, afternoon, or good evening. And thanks for spending your Sunday. Unless you are maybe in Australia, then it's already Monday. But thanks for spending your Sunday with us today. Before we start, just a brief introduction. Even though Temidayo already did a perfect intro to myself, I would just like to add, because he also asked me before the session, where does this data Mozart comes from? Is it like for my passion about the music? I would lie if I say yes, so it's no. I explained that basically I'm located in Salzburg in Austria, and Salzburg is worldly famous as a birthplace of Wolfgang Amadeus Mozart. So I was brave enough to use his last name as part of my nickname. That's where this data Mozart come from. All the other things you've already heard. I like Power BI. I like everything related to data. And yeah, I'm working with mostly with Microsoft data platform products in last a lot of years. Okay, so our today's topic is related to Power BI performance tuning. And in the very beginning, let me be honest with you. Creating Power BI report may look like an easy task. So you import the data, you set those nice colorful visuals, and your shiny dashboard is ready. However, one day you receive a phone call from the report user who complains that her or his report runs very slow. Or what's even worse, your scary old DBA walks into your office and asks to explain why your report burns all the available resources within the company. So that may happen. It may happen also that no one comes to you, but you simply see that that's not it. So the report doesn't perform well. As I've already told you, creating a Power BI report is not a rocket science, to be honest. But in the end, there is a huge difference between a Power BI report that works and Power BI report that works efficiently. Now you're probably asking yourselves, if I have performance issues, where should I start? And that's a great question, believe me, because once you identify the area or the areas that causes problems, you are halfway throughout the solution. Maybe not halfway, but you can then shift your focus to finding a solution to more specific issue. And talking about the different areas that can cause issues to Power BI performance, there are at least 5 key areas to examine if you want to improve the performance of your Power BI reports. We will cover, of course, all of them today. First one is the data model size, then data refresh process, DAX calculations, visualizations, rendering time, and storage mode choice. So let's go now and try to understand each of these areas in more depth. And I will show you some potential caveats and how you can avoid or overcome those caveats. And I will also try to share with you some best practices for getting the maximum performance from your Power BI solution in multiple different scenarios. So the first thing I would like to discuss is your data model size. It is so important that in certain scenarios, for example, if you are operating on Power BI Pro license, which has a 1 gigabyte limit per dataset, your solution simply can't be used if you reach that limit. Data model size also affects our next talking point, which is a data refresh process. As you may assume, the larger the model, the more time and more resources will be needed for the data refresh. Essentially, tabular model speed is based on keeping data in memory, so keeping data in RAM memory. So the smaller the memory footprint of your data model, the faster it will be, obviously. Now, to understand what affects your data model size, we need to lay some theoretical background in the beginning. First of all, when you choose import mode, so now we are talking about import mode in Power BI, data is being stored in a columnar database which is called VertiPack. What VertiPack does, VertiPack keeps the snapshot of your data in memory. And then this snapshot can be refreshed periodically from the original data source. To understand how things work in the background, you should be able to distinguish between formula engine and storage engine, two key components of this underlying architecture. Formula engine represents the brain of Power BI. It translates, so when you write DAX, formula engine translates DAX to a specific query plan, and that query plan consists of set of different physical operations such as joins, aggregations, filtering, and so on. So once the formula engine generated the query plan, then storage engine jumps into the action, and storage engine represents the muscles of Power BI because it literally physically goes through the data stored in the tabular model. So if storage engine needs to dig through massive amounts of data, it would obviously need more time and more resources. And I always like to give this analogy when explaining why data model size matter. Imagine that you have to find a book in your old attic, and what do you think? Would it be faster and easier to find it if you have, just a few items around, or if your attic is in complete mess and full of all kinds of stuff? I guess you all know the answer. So optimizing data model size is a really broad topic. I also have a session which is 60 minutes dedicated just to this specific topic. So let me just here list some of the best practices related to data model size optimization. First of all, and I would say this is the most important one, reduce the data you are importing in your data model and keep only those rows and those columns that your users really need in the report. That means first of all, remove unnecessary columns. Also, when you're talking about removing unnecessary rows, I'll give you a very common example. If your users need to analyze data from last 2 years, then there is no need to import the data from last 5 years. Just import what is needed in the report. The next one, try to reduce column cardinality whenever possible. Uh, Cardinality stands for the number of unique values in the column. And because Vertipaq stores the data in a compressed way, the lower the cardinality, the easier will be for Vertipaq to compress the data and to build the dictionary of these distinct values. That means in real life, translated to real life, if you don't need data on a day level, on a level of granularity that is lower than day, then remove time portion of the data, and that will significantly reduce the size of that column. I will show you in a few minutes in one example what I'm talking about. Next one, avoid using DAX calculated columns whenever possible, because simply said, they are not optimally compressed. Instead, try to push all your calculations to a data source, like SQL database, for example, or perform them using Power Query Editor. This one is maybe obvious, maybe not for many of you. Disable auto date time option for data loading, because this will remove a bunch of automatically created hidden date tables in the background. Instead, always and literally always create a proper calendar or date dimension, however you like to call it, and have it in your data model. Okay, so let me show you one of these points in action. So I will switch to Power BI desktop, and let me show you what I have here. So this is my chats table that contains let's say 9.3 million rows of data. So that's nothing special in terms of volume for Power BI. But what's the catch here is that data is being stored for the I have a column which is called date TM start UTC, which is date time data type, and it's imported as it is, so as a date time data type. That means, for example, let me show you in Power Query Editor. Okay, so here is our column, date TM start UTC. So it goes to the second level of precision, or to be more precise, it goes to milliseconds level of precision. But here it goes to so you see we have a date, we have hours, minutes, and seconds, and it's imported as it is. So if I now open DAX Studio directly from Power BI desktop, and first of all, I sincerely hope that you are all not just familiar with DAX Studio, but that you are also using it, because it's a super cool free tool that will immensely help you to speed up your Power BI development. So now when I open DAX Studio, I will go here on the top to Advanced tab and click on View Metrics. Once I do this, this will launch Vertipaq Analyzer, which is also another separate tool, but it's also built in DAX Studio, and you can use Vertipaq Analyzer to analyze different metrics, different numbers behind your data model, and to understand how your data is distributed, what is the size of different structures in your data model, like relationships, tables, and so on. So if I take a look at our chats table, because now we are interested in that one, you may see that this date TM start UTC column has a cardinality of almost 9 million. So almost 9 million. That's the number of distinct values in this column, date TM start UTC. And total size of this column, so just to be clear, all these numbers are in bytes. So the total size of our date TM start UTC column is 454 megabytes. That's the size of just one single column. And you see that data takes 26 and dictionary takes most of this figure here. So basically this number is just the sum of these three: data, dictionary, and hierarchy size. So total size of the column is 454. Just try to remember this number. So what I'm going to do now, I will just change the data type of this column. So in real life, you don't need to analyze data on a second level of precision. That would be, I would say, maybe 1 in 1,000 reports that you've built, you need to analyze data on a second level of precision. For all the others, it's either hour level or day level. In most cases, I would say day level. So let's go and change the type of this column from date time to date. So you see that now I got rid of time portion here, so I have only date here. Let's hit close and apply and wait a few seconds for Power BI to reload the data. We have 9.2 million rows. That's it. So this number here should change. Yeah, we now, instead of almost 9 million distinct values, we have 1,356. And if I go now to DAX Studio and click again on View Metrics, and let's expand our chats column. So date team start UTC, we have, as you saw in Power BI desktop, we have 1,356 distinct values. Instead of 454 megabytes, now this column is less than 7 megabytes. So basically, just by removing this time portion, which is completely useless in our reporting scenario, we reduce the size of this table and of this data model like 85–90%. So just by changing data type. And I would say checking which columns are necessary or how you can reduce this cardinality of the column. This should be your starting point when you are tuning the data model size and try to make your data model more efficient. So reduce cardinality. That's the main thing to keep in mind. Fine. Now that you know how to optimize your data model size, your data refresh process will run much faster. And that's true, but not in 100% of cases. I mean, if it's simple as that, then this session wouldn't have existed. So as I've already explained in the previous part, Vertipack keeps the snapshot of your data in memory. And then you are refreshing this snapshot from time to time, depending on your specific business needs. It can be once per hour, once per day, once per month, and so on. Now, chances are that you are applying some transformations to your data before you load it into Power BI. That can be currency conversion, different data filtering, renaming your columns, performing some calculations, and so on and so on. So where do you shape your data? Source database. That's the most obvious choice, and in most cases, I would say the most desirable scenario, which is based on these traditional, well-established extract, transform, and loading principles and processes. If you don't perform data transformations on the source side, the next station is Power Query. What is Power Query? It's the built-in tool in Power BI that enables you to perform all kinds of transformations to your data. Last time I checked in Microsoft's official documentation, you can apply more than 300 different transformations. The key advantage of Power Query is that you can perform all these transformations, and there are really some complex transformations in there with little or no coding skills at all. What's even more cool, all steps that you apply during the data transformation process are being saved. So every time you go and refresh your data set, those steps will be automatically applied to shape your data and prepare it for your Power BI reports. Under the hood of Power Query is a mashup engine that enables this data shaping process to run smoothly. And Power Query uses very powerful M language for data manipulation. So keep in mind, M language is for Power Query, DAX is for Power BI. For some data sources, such as relational databases, but also non-relational data sources, for example, OData, Active Directory, or Microsoft Exchange, this mashup engine, which is behind the scenes in Power Query, is able to translate M language to a language that this underlying data source that you are connecting to will understand. In most cases, we are talking about the SQL language, of course. Now, why is that important? Why does that matter? Well, by pushing those complex calculations and transformations directly to a data source, Power Query leverages capabilities of those robust relational database engines that are built to cope with large amounts of data in the most efficient way. And that ability of Power Query's engine to create a one single SQL statement, combining all the M statements behind your transformation, is what we call query folding. Or let's try to make it simple. If the mashup engine is able to generate a single SQL query that is going to be pushed and executed on the data source side, we say that the query folds. Query folding is an extremely important feature in Power BI, and as such also deserves a separate 60-minute session to get familiar with all the capabilities and limitations. And I really like to quote my friend Ben Watt, who is running Dublin Power BI user group, who once told me that for him, query folding is the unsung hero of Power BI, and I completely agree with that. So query folding is a real unsung hero of Power BI. So I want to show you today how this feature may increase efficiency or decrease efficiency of your data refresh process. So let's go again to Power BI desktop, and here you see that I have just a card visual that shows me the total number of records in my fact table, which is 12.6 million rows. So let's go and apply some transformations in Power Query Editor. This is our table. So far, I didn't do anything, so I just import data as it is. So let's go and, for example, take from dim customer table, let's take first name, last name, and gender. Okay, then I will, for example, make all the first names uppercase. So some of those transformations doesn't make sense in real life. I just want to show you what's the difference in performance with or without query folding. Then, for example, I will go, let's find sales amount, here it is. And again, I will transform this. Let's calculate the absolute value of sales amount. Then, sorry, I forgot before that. So uppercase text. And now I want to change the type of this column. So like in previous case, I will change the type of this column from date time to date. So just get rid of time portion here. Now let's go to sales amount and transform this to use absolute value. Then what else can be done? Let's find total cost, for example. Let's keep only those rows where total cost is greater than 5, for example. Then let's do a replacement. For example, here I will replace values. So I will replace F with female. And finally, let's say that I'm interested only in big sales, big orders. So I want to keep only those records where sales amount is greater than 500. Okay, so I want to remove all the records where the sales amount is lower or equal to 500. Okay, fine. So how do you check if the query folds? If you right click on this last step in the transformation pipeline here under applied steps, and this view native query option, you see that it's clickable. So I can click on it. So let's click on it. And here is our nice SQL query generated automatically by Power Query Engine. So as you witnessed, I didn't write a single line of code, neither in M, neither in SQL, but I was just clicking here and there. Power Query generated M formulas for me, and in the background, it was also able to translate this M transformation sequence of M transformations into the one single SQL statement. Now, this, if you're coming from SQL world, this is maybe not the best and not the most optimal SQL statement, and I'm sure that someone who is experienced in SQL can write this to be more efficient. But keep in mind that Power Query does a hard job, and it will always return correct results. So it's not always the most optimal query, but it's the correct query, so you will get the results you asked for. So what do we have here? You remember I uppercased first name column, so you see that there is an equivalent in SQL language upper function. Also, I converted date time column date key to date. I calculated the absolute value of sales amount. I also replaced F in female, and that's super cool. But what's more important is down below here. Let me show you. This line here is the key for this query to perform well. Why? So just imagine now, this is Power Query Engine, this is SQL Engine, and now they are talking. And Power Query Engine says, hey, SQL Server, I need some data for my Power BI report. Okay, which data do you need? I need, I want you to send me all the sales and I want to do replace of F to female and I want to, okay, but how many records do you need? You know what, I just want records where the sales amount is greater than 500. Tell me that, yeah. So SQL Server applies this filter, and instead of sending all the rows, you see that we now have 12.6 million rows. If I click apply changes, let's wait. And first of all, watch out what happens here. So we got 1.5 million records back from our SQL database in like maybe 10 seconds, approximately 10 seconds. Now let me show you what happens when there is no query folding in place. So now I will intentionally break query folding just for the demo purpose. Of course, you shouldn't do that in real life. So this is just to show you the difference. So now in this case, I know that this is the step that will break the query folding where I changed the data type of my date key column. So I'll delete this step. And now we have again date time. In this case, instead of change type and selecting date, I will go to transform and select date only. So just pay attention. This is the same outcome. So yeah, I will insert the step. So you will see again, this column will not contain the time portion, only dates. But now if I right click on the last step, you see that view native query option is grayed out, which means that I cannot click on it. And in 99.9% of cases, that means that query doesn't fold. So if I click here, it's also disabled here also. And as I said, I know that this is the step that breaks the query folding. If I click on calculate absolute value, this one still folds. So I can click on this step, view native query, because query folding is not all or nothing process. So you can still get some benefits of partial query folding, but once it's broken forever. So you can't achieve it anymore. And that means, again, I have my absolute value and I have my upper. There is no replace here, and there is no convert. But what's more important, there is no where clause down below. And let's see what is the impact of this. So if I hit OK, and let's hit apply changes, and now wait for Power BI to again reload the data. So we know we should expect 1.5 million rows. That's it. Oh, so what happened here? We know that we should have 1.5 million rows. So why Power BI continue to load the data? Because there is no where clause. So SQL Server didn't have idea that we are interested only in those rows where the sales amount is greater than 500. So what happened again? They were talking, and Power Query told SQL Server, give me all the information, but since we don't have this where clause down below, SQL Server pushed all the records from the table, so all 12 million records, and then within the mashup engine, Power Query applied transformations that will show in this final result that we have in the report. Or we should expect to have this same number here, 1.494 and something. So you see that instead of 10 seconds, it already takes more than 1 minute. And I don't need to tell you in terms of resources, what is the difference between transferring 1.5 million rows and 12 million rows. As I said, again, the same result, the same outcome, but this time without query folding, this was way worse in terms of performance, both in terms of time and resource consumption. So mashup engine had to pull all the data from the source. Don't forget that. and then apply transformation steps that we defined. Okay, going back to our presentation, and let's list all the best practices, or try to list all the best practices related to data refresh process. So if you identify that your data refresh process takes forever to execute, maybe it's a good idea to check it. And the first thing I'm going to recommend here is a fantastic blog post from Phil Seamark. Phil Seamark works for Power BI customer advisory team in Microsoft, and you can find on his blog many great articles. This one is where he explained how you can visualize data refresh process and quickly identify potential bottlenecks. Some general best practices in order to speed up the data refresh process in general and keep the query folding in place would be, first of all, push calculations and transformations as close to data source as possible. For example, if you have permission to create database objects, you can encapsulate all the necessary transformations within the database view, and then you can import that view in Power BI. Views, same as regular tables in Power BI, are foldable objects, so you can also achieve additional query folding over those database views. Once again, query folding is not all or nothing operation. That means if you have, let's say, 8 transformation steps within Power Query, and your query folds until 6th step, you will still get some benefit from partial query folding. However, once the query folding is broken, it can't be achieved anymore. Even though you have some foldable transformations there, once it's broken, it's broken. Keep that in mind and try to push all those steps that you identify that break query folding. Try to push them down this transformation pipeline as much as possible. And one more thing, turn off allow data preview option, allow data preview to download in the background. Why should you do this? Well, when you are in Power Query Editor, you see the preview of the data for every transformation step that you applied. So when you hit the refresh, it's not only the amount of data that gets loaded into your data set, but also a whole bunch of different queries to refresh this preview. And in some situations, these queries take more time than the loading data itself. One important disclaimer here regarding this one, the last one, turn off allow data preview. This is relevant only for Power BI desktop, so it doesn't. It's not relevant for Power BI service. So if I have to choose one single rule regarding data refresh process, and let me call it the golden rule, that would be a famous Roche's maxim. So Roche is Matthew Roche from again from Microsoft's Power BI customer advisory team, and I like always to quote this sentence, which says, push your transformation set calculations as upstream as possible and as downstream as necessary. This should be your transformation mantra every time when you are working with Power BI. Okay, so hopefully we are now done with the background problems and we are slowly navigating to user interface. And honestly, that is the area of Power BI where performance issues are easiest to spot. And I'm sure that, and we all have been in that situation, sooner rather than later, someone will come to you and say, hey, why is my report so slow? Of course, there can be a whole bunch of potential reasons, but let's focus on a few that are most often responsible for the poor performance and bad user experience. So once you import the data in Power BI, I assume you will start writing DAX measures to satisfy various business requests. For example, you need to provide business decision makers with the metrics such as the number of unique customers, top performing products, running total of sales amount, and so on and so on. So there are literally infinite number of potential calculations. The beauty of DAX, and I intentionally put this word beauty under double quotes, is that you can achieve the same result in multiple different ways. And I will definitely not go deep into DAX logic in this session, explaining filter contexts, context transitions, and so on. as there are many people around who know DAX much better than I will probably ever know. But however, I wanted to show you a few certain situations that I've seen many times during my work with Power BI, where little nuances in your DAX formulas can take you in the direction that you wish to avoid. Okay, so let me show you one basic example of how misusing DAX calculations can cause a significant performance decrease in your Power BI report. Okay, so let's go to Power BI and DAX. So what I have here, I have a total number of sales order, big sale orders. So those are orders with sales amount greater than 500, like in previous example, and broken down on a day level. So for every single date, I have the number of big orders. And this is a simple definition. So I'm using distinct count function to count the number of unique sales order numbers and show that in this table visual. I've used this because I will run all of next queries I will run in the DAX Studio. This is just for the comparison purposes, so we are sure that we are returning correct data by using DAX Studio. Don't forget, performance is important, it's very important, but the most important thing is that you get correct results. So if you get results fast but they are incorrect, that's not good. So let's go to DAX Studio and let me quickly put here a DAX measure. Okay, so I'll not write from the scratch because we are limited with time, but I will explain everything, so don't worry at all. So I'm basically here defining the measure which will be called total big orders in my online sales table, and this is my distinct count like you saw in Power BI desktop. And here to mimic the situation, so it's not 300, it's 500. I'm using filter function to define the filter on the online sales table, which says sales amount, value in sales amount column should be greater than 500. And basically here, I'm just returning those two columns. And let's turn on server timings, and let's clear on run. That's fine. And let's run this query. Let me check what happens. So, yeah, okay. I have different table name. Okay, here as well, and I think here, and I think that should be fine. So let's clear cache and run. No, here it is. Let's now run. No. Yeah, one more thing here, and that's fine. Sorry for that. So I changed the table name, and that caused the problems. Okay, in the bottom right corner, so here you see the time elapsed for executing this query. So it's already more than 12 seconds. We'll see what will be the final number, 16.7. So if I now go to server timings, and let me show you what we have here. First of all, let's go to results and check if the numbers are correct. Remember, numbers, correctness of your numbers is the most important thing. So it's 653,785,713. So if I go to Power BI desktop, okay, we see that we are correcting correct results. And now you're probably proud. I wrote DAX measure, it works, it returns correct results. Yeah, but it takes more than 16 seconds to execute. And if I go to server timings, you see that the total time for this execution was 16.7 seconds. On this, I have pretty strong machine, I would say. So on some weaker machines, it will take maybe even more than that. So what's the issue here? We see that we have a bunch of queries here in our central window, and each of them took like 15 milliseconds in average, 14, 15, 16, 13, and so on and so on. But the problem here is that we have 1097 queries, storage engine queries. So what's wrong with this measure? Basically, what's happened here is that what formula engine did here, for every materialized table, for every single date, it ran a distinct count against each set of data specified in our filter condition, date by date. So we have 1097 dates in our data set. For every single date, we have a separate query with this distinct count. So one query was ran for each date. Now I guess you assume that there has to be a more optimal way to obtain these same results. So let's rewrite our measure. And in this case, I will just copy paste. And here I will change this from filter, I will add all. And instead of providing the table as an argument, I will do like this. And this, it's maybe not formatted. So let's, because they say if it's not formatted properly, then it's not text. Let's say filter greater than 500. I missed something, so let me check once again. Filter all. Okay, I need to remove all the filters first from the column and then close this one and then close this one. This should be fine. So let's format it now. Not really. We need comma. And now it's okay. And let's run this query. So total big orders, it's not bad. This one, this guy I will call good. You will see why. So let me grab this query and clear cache and run. So it's already finished. It's already completed. Let's go to results. You see that the numbers are exactly the same like in the previous cases. If we go to server timings, it's 35 milliseconds. Instead of 17 seconds, now it's 35 milliseconds. And there is only one single storage engine query to retrieve all the data. What's the catch here? So those two measures look very, very similar. In both cases, we are running distinct count, and in both cases, we are using filter function. The only difference, but the big one, that's why I said sometimes nuances can make a huge difference. Here, the nuance is that in this case, by using filter function and providing the whole table as an argument, engine had to materialize the huge table of 12.6 million rows and many, many columns. I think maybe more than 20 columns. While in another case with the fast measure, by adding this all function within the filter function, what we did here. So basically with this all function, we removed all the active filters from sales amount column. So that's the first step. We removed all the active filters. And then we applied our filter, which says, give me only those rows where sales amount is greater than 500. So instead of providing the whole table as an argument, in this second case, we provided just a single column as an argument. And as you've seen, this ran much, much, much faster than in the previous case. One more thing that I want to show you is if I just remove this portion here and leave it like it is. So let's run this one. Yes, bracket is too much. Okay, again, this query completed very fast. Results, let's first check results. They are again the same. Server timings, 31 milliseconds. That's the same as in the previous case, 31, 35 milliseconds. Doesn't make any difference because the query plan is exactly the same, 100% same. This is just a syntax sugar of the previous measure definition. So even though if you write it like this without filter and all with this verbose syntax, what the engine will do in the background is it will implicitly wrap your measure definition. It will implicitly wrap with this combination of filter and all. So this is just a syntax sugar. The measure is completely the same in both of both in terms of performance and everything else. So you remember when I told you that the beauty of DAX is that you can obtain same results in multiple different ways. And I want to show you the fourth measure definition that will return the same results. In this case, I will use keep filters function. So just a disclaimer, this function is not the same as the filter function, but in our scenario, I expect to for this function to return the same result. So the only difference is that here I will wrap this with keep filters, and now I hope that I make a good syntax. Let's run this. Yes, so again 30 milliseconds, again very fast. Let's check results, and bam, this is the fourth way to get the same results with in a fourth different way. And you saw 3 of them are good, 1 is bad, but be careful. The key takeaway from this lesson here is don't filter tables, always filter columns. Just 1 column or just a few columns, but avoid filtering whole tables. Okay. This one is the most obvious problem, I would say. When your report page renders slow, you can bet that the report consumers will complain about the poor experience and ask you to do something. So what can be done? Let's see, first of all. First, let's check what can be a root of the slow rendering. At first place, PowerBI offers you a very handy built-in feature, which is called Performance Analyzer. And Performance Analyzer enables capturing performance metrics for every single visual that you have on the report page. The rule of thumb is, as you may assume, the more visuals you have on your report page, the longer time would be needed for rendering that page. And I'll show you in a few minutes how this looks in reality. So let's go to Power BI desktop, and here I will go to View tab and turn on Performance Analyzer, and let's start recording. So what I have here, let me show you. Once I hit refresh visuals, and let's go and sort them by total time in descending order. So we immediately can see which report element on our report page was the slowest one, which one required most of the time for rendering. And that's this card visual, this one here, total sales quantity, which took 232 milliseconds, which may sound like not too much, of course, but keep in mind that these are just really simple DAX measures. So just sum, max, mean, average, and so on. So nothing special, nothing complex here. And still, this one took almost quarter of a second. And if we take a thorough look here, you see the DAX query took only 3 milliseconds. That's super fast. Visual display 7 milliseconds. That's also fast. But this other took almost all the time from this 232, like 90%. Now you're probably asking yourself, what the heck this other means? And this is a great question. So let me quickly answer it. Other means how long did specific visual had to wait for other actions on this page to complete before it could be handled. Don't forget, Formula Engine works in a single-threaded way, so it can't generate the DAX query for multiple visuals in parallel. So it's one by one. So we have here 10 card visuals, and this is the performance of our 10 card visuals. So if I go now here, and you see that this report page looks exactly the same. But let's start recording now, refresh visuals, and this one maybe it's not. Yeah, okay. So now it's from cache, but never mind. In this case, I have 2 matrix visuals that contain exactly the same data, exactly the same measures, and with spending some time on formatting this matrix visual, I was able basically to mimic the look and feel of the previous report page. But in this scenario, instead of running 10 separate DAX queries, in this case, I have only 2 DAX queries. One DAX query which populates all the 5 measures in the matrix on the top, and one DAX query that populates values in the matrix at the bottom. So this is a feature in Power BI called DAX Fusion, where formula engine in certain scenarios, when you put multiple measures within one visual can combine all your queries into one query, fuse them basically, and in one run return all the 5 results. So this is just a basic example, and I need to give a credit for this idea to Chris Hamill. He came up with this solution, how to format and adjust matrix visual to remind of card visuals in the report page. Okay, so here's the list of things you should do or not do when it comes to performance of your visuals. First of all, very obvious, but very often overlooked, reduce the number of visuals on your report page. If you don't need the visual, simply remove it from the page. Also, having multiple non-data related items such as shapes, images, or text boxes will also impact the rendering time. Therefore, if you plan to have a lot of those shapes and icons, images, and I don't know what, consider using PowerPoint. There you can create your desirable page design with all those elements, with all those nice rectangles, icons, and so on. And then you can save this as an image or SVG file, and then you set this image as a page background in Power BI. So instead of having, I don't know, 10 different elements, you will have just one. Also, reducing the number of visuals on your report page will mean that, like in our example, if you have a possibility to satisfy the business request by generating one DAX query instead of 5, you should tend to do it, of course, whenever possible. Next one, try to display data at low level of grain. So Vertipaq is really brilliant in vertical aggregations, but performs much worse on a detailed level of reporting. With that in mind, if you have, let's say, a table of 40, 50,000 rows and some measures being calculated and executed row by row, you should be better off keeping this high level detail by taking advantage of, for example, drill through feature. So always display aggregated data in the table by default, and then give user a possibility to drill through or to specific set of rows or specific row if necessary. Also, if you have a lot of visuals on the report page and don't necessarily need mutual interactions between them, consider disabling those interactions, consider disabling cross-filtering. It can also be a cause for performance problems. And final one is sync slicers. I saw this many times. If you have complicated slicers in many report pages and you choose to synchronize all of them, sometimes this can also be a performance killer. Okay, honestly, maybe I should have placed this problem in the beginning, as decision which storage mode to use is one of the first you need to make when you're starting your Power BI solution. However, I've intentionally left it for the closing part of this session, and I believe I have a good reason for doing this. Why? Because I saw a lot of times, really, when someone thought that poor report performance can be improved by switching to direct query mode and going back to one of the things that we learned previously, leveraging capabilities of those robust database management systems that are built to efficiently cope with huge amounts of data. How wrong is that assumption? I mean, in reality, those systems are built to cope with huge amounts of data, but in a whole different scenarios than direct query with Power BI. So before I explain you why you should avoid using direct query, let me first briefly explain what is a direct query at all. So when you choose direct query storage mode for your tables, this means that the data is being retrieved from the data source at the query time. And this also means that the data lives in the original data source before, during, and after the query execution. So no real data is going to be stored in Power BI. Thinking that using direct query mode will improve your Power BI report performance is one of the biggest fallacies. So direct query will never ever improve performance of the Power BI report. Period. That's it. To cut the story short, you should use direct query literally in three and only those three scenarios. First one is your data size is so large, so we are talking about billions of rows, many columns, and so on, that you simply can't import it in Power BI. For Pro license, don't forget we have this limit of 1 gigabyte per dataset. For premium, with enabling large dataset, I think you should never run into issue to use direct query because of this reason. The next one is a legitimate one, so requirement to have near real-time reporting solution. As you already learned, when you use import mode, Power BI keeps the snapshot of your data, so snapshot from the certain point in time. Now let's say that the requirement from your users is to have data with maximum 1 minute latency. Obviously, you can't refresh data so often to satisfy this request. However, don't fall into this trap if your users request real-time data. From my experience, when I asked them what is real-time data for you, I was getting a whole myriad of answers like, yes, for me, real data is every morning when I come to my office and I turn on Power BI, I want to have the latest data every morning. So that's every 24 hours. Or someone told me it's once in the morning, once before I leave the office. So it's twice per day. So you can refresh data using import mode. So explain your users all the downsides and potential problems of using direct query. And from my experience, in 98, 99% of cases, users will admit that maybe they don't really need real-time data. And final one, third one is when security policies are defined on the data source side, because report consumers' credentials will be propagated to this underlying data source and security rules will be applied there. If I still didn't convince you to avoid direct query, you simply must go this way for any of those reasons that we mentioned. Here is the list of general rules that you should keep in mind in order to get the maximum performance when you are using direct query storage mode. The first thing is one huge if. So if you have permissions on data source to perform some changes on the data source, there are multiple ways to improve direct query performance. First, you can create proper indexes to support your most frequently run queries. Also, you should ensure that data integrity is in place. And finally, if possible, create a persistent data objects in the database, such as tables, or even better, materialized or indexed views, which will persist all the necessary transformations and calculations. If you don't have access to an underlying database, you can still gain some improvement within the Power BI itself. The most important thing is avoid complex Power Query transformations. As you already seen, SQL that's being generated automatically by Power Query engine is not always the most optimal one. It is correct SQL, but often is not the most optimal one. So if you need to use calculated columns, try to push their creation on the source database and keep them persistent there. Also avoid complex DAX measures. Avoid relationship on GUIDs. GUID is a special data type that exists in many relational databases. That's a unique identifier. Power BI simply doesn't support this data type and needs to apply some data conversion during the query execution, which obviously affects the performance. Here, the solution is to convert this data type within the source database before Power BI generates its own queries. Limit parallelism and apply query reduction, two options that you can check within Power BI desktop under options and settings. And also you should check assume referential integrity option that will enable usage of inner joins instead of outer joins, which should in theory and in most cases in reality, which should improve the overall query performance. Of course, as a prerequisite, you should have referential integrity in place within your source database, but I hope that's the case nevertheless of Power BI. So to conclude, the best practice regarding direct query storage mode is avoid direct query if possible. Okay, we covered a lot, and in my opinion, this talk is probably more suitable for, let's say, 90-minute duration, but let's try to wrap up the key takeaways from our today's session, or I like to call this one Monday to-do list. So things that you should do once you go tomorrow to your office and turn on your PC and start working with Power BI. First of all, the key thing is to identify which part or which parts of your Power BI solution don't perform well. If your data model size is large, consider removing unnecessary rows and columns and try to reduce column cardinality, for example, like you've seen by removing time portion from your timestamp columns. If your data refresh process takes a while, check if the query folding is in place. In case that you identify the step that breaks the query folding, try to push it down the transformation pipeline as much as possible. Next, be mindful and be careful when you write DAX to enhance your data model with additional columns and measures. For example, don't forget, if you need to filter the data, filter columns, not whole tables. If your report page renders slowly, try to reduce the number of visuals on the report page, and take advantage of performance analyzer to identify bottlenecks, and don't use many visuals that calculate single value, such as card visuals, for example. Finally, stay away from direct query storage mode if possible, and use it just in those 3 scenarios that we've already discussed. Now, of course, you should keep in mind each of these points, but if you ask me, one of them is slightly more significant, and that is number 1. Because identifying which part of your Power BI solution is the root of the performance issues will help you to focus on solving a specific problem rather than wasting time on less important stuff. That's it from me. I would like to hear if there were any questions. Feel free to drop them in the chat window. Let me just open the chat.
Awesome.
We are slightly above 60 minutes. Apologize for that,
No
but
problem.
I hope it's okay.
It's fine. It's fine. So Antonio said, all clear. So if you have any question,
Yeah, what Brian said, tool that he found really useful is Measure Killer tool. Yes,
you can raise your hand. I can
that's.
make you a speaker. Oh yeah.
Can you hear me?
I can hear you. You're audible. You're
Okay.
audible.
Yeah. So I've just seen what Brian wrote about the tool for reducing data model size, Measure Killer tool, which will automatically generate M code to delete unused columns in data model. Great advice, great tool. I know Gregor, guy who developed the tool with his team. I know him personally, and I know how much effort they spent on it. And it's amazing. You should try it, definitely. It's also free, so it's really helpful. Great suggestion, Brian.
Yes. I think I'll check that also. So if you have any question, you can put it in the chat box below. Okay. So as we're waiting for question, right? So Nicholas, remember the 2 questions I asked? You're going to tell us at the end of the section. So the first question will be, everyone is saying clear so far. The first question will be, how you started your whole data journey, and what advice for people just starting out in the data field? Okay,
Yes.
someone said, very informative. Quick question, maybe unrelated. To what extent can Python replace Power BI?
That's a hard question to be answered here. I would say Python is not here to replace Power BI or vice versa. They are here to supplement each other. So I would say it's not a replacement, definitely.
Definitely also. Yeah, definitely. Okay, someone said that is. You can read the question. You can see the question, right?
Yeah. Is there an optimal number of visuals that should be on a report page? That's a good question, and I often being asked that. So there is no golden number like 10 or 15 or 20, but from what I've heard of from many people that are along in this, you should try to keep it below 15, so up to 15. Whenever you come into the situation that you have, like, I don't know, 25 or 30 different visuals, it's a good idea to think maybe to include other report page to extend your report with another page. So don't put everything in one single page.
Awesome, 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 awesome. So you guys can keep the question coming in. So before other questions, so Nicholas, the question asks for you: how you started your own data journey, and what advice about people just starting out in the data field?
Yes, so my data journey started long ago with working with relational databases. So with SQL Server 2005, I think, or maybe it was also 2000. I can't remember. It was a long time ago. So I used to work with this traditional Microsoft database stack and business intelligence stack, SQL Server, analysis service, integration services, reporting services, and then I switched to Power BI in 2017. So yeah, that was my journey. I like to say that I finished in Power BI by accident, as no one in my company once we installed Power BI report server and Power BI as a part of it. So no one wanted to use it for the first few months from my team. So I started, and then day by day, month by month, and yeah, that's how I went into it. But SQL is still my first love, so I still like and enjoy writing SQL.
Okay, okay. So the second question will be: what advice about people just starting out in the field of data?
Uh, the main advice is to. It sounds simple, but it requires a lot of self-dedication. So learning. Uh, we all learn every single day. So try to be better version of yourself in terms of data topics today than you were yesterday, and of course tomorrow try to push those boundaries even more. There are many fantastic free resources around, so there is no excuse of not learning things. So you can, if you prefer videos, blogs, I don't know, live sessions, courses, whatever, everything is available. And so learning, that's the first thing. uh, if you're talking specifically about data related topics, try to learn those basic, more generic concepts. So don't just learn how to create visual in Power BI. Try to understand data modeling. Try to understand, I don't know, how DAX works. So all the things that are more generic than building a simple report. Because once you understand those concepts, you can also work with other tools, or you can be more productive and more efficient in Power BI itself.
Okay, awesome, 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 awesome. Can I? I've actually shared your LinkedIn. Can I still share it again? So you might not connect with you on LinkedIn.
Yeah,
Is it okay
absolutely.
by you?
Yeah,
Okay,
sure.
so I'll drop the comments in the section. So if you want connect with Nicholas on LinkedIn, you can always connect with him. So if there's no question, I think we're wrapping up very soon. So Nicholas, I want to say thank you very much for honoring our invitation. You're someone we look up to. I definitely look up a lot to you. I follow your post on LinkedIn a lot, and also at least you finally explained the whole concept of music in data. So it's cool. It's cool. Okay, so let's
Thank
ask
you.
now, how does one add value as a member of a data team?
Yeah, that's a good question, but I would say there is no one single specific answer. So you can add a value as a member of data team in multiple different ways. You can, for example, be specialist for some niche topic related to data. So there, the people from your data team are not familiar with. You start working on it, and you become more and more proficient. You add value as a specialist for certain part. Or you also can cover a lot of different things, so you focus on getting a broader knowledge, and then if some of your colleagues leave or they are not currently there, you can jump in and cover different roles in that team. So these are just two things that came to my mind firstly, but yeah.
You're absolutely right. So I think that's one of the best ways to like give yourself more value, like doing things that other people don't know how to do. Okay, so let's ask now, what's your opinion on DP 500 certification?
Yes. So it's a broad one, so it covers 49 different topics, 49 skills, all listed officially. So I took this one. I took also for Azure Data Engineer DP203, which was previously consisted of 2 different exams. So now it's one, and I would say DP500 is more like 2 exams in one exam. So a broad range of topics, advanced Power BI. So if you never use Power BI, my friendly advice is don't try this exam. So it assumes that you already have some level of knowledge in Power BI. So it's advanced Power BI topics. It also covers Synapse Analytics and to some small extent also Purview. But I would say if you are good with Power BI and if you know the basics of Synapse, go ahead and you should pass it successfully. Yeah, already have PL300. That's good. Then you know the basics definitely of Power BI and you are ready for the next level. So in my opinion, this is next level of Power BI and combination, yeah, with yeah, Synapse, just basics, nothing, not some yeah, details.
Awesome. So I think everyone else take the DP 500. Should have the basic knowledge of Power BI and also Synapse Analytics. Okay, so Nicholas, I don't know how to tell you thank you right now, but I'm so honored. Like, it's not every day we get to have Nicholas on that. I'm like, whenever you post your blogs, it's always like, I follow your blogs a lot. I read it a lot. So
Thank you so much.
you can also share you can share a link to your blog also, and if you have a YouTube page, you can also share it also.
Yes,
Okay,
I have YouTube page, but I'm not very proud. I can't find time to record videos consistently. So
okay.
I'll put link to blog.
You can put your blog link. Yeah, definitely.
Thank you very much for inviting me.
Awesome.
It was a real pleasure to present for your user group.
Awesome.
And Antonio, yes, see you in March in Barcelona. Yeah.
And so I think we're wrapping up the session now. So thank you, Nicola. So I'll say have a lovely week ahead, guys. Bye. And have fun, guys. Bye, everyone.
Bye, everyone. Thanks for
Bye,
joining.
everyone.
Thanks, Brian. Thanks.